Section 4.4 is about applying what we learned about quadratics in 4.3. And so it is literally just a handful of word problem application type problems. And I'm going to work through one of them right here. The price P in dollars and the quantity X sold of a certain product satisfy the demand equation. So the number of sold is equal to -6 times the price plus 600, as in the higher the price, the lower the demand, the lower the amount sold. So we're talking about revenue in this, and revenue is simply the number sold times how much you sell them for. So we have X, that equation that represents the quantity sold times the price. And what that gives us is a revenue function. So it says, what is the domain of revenue? And so the revenue function is simply that what is used to model how many are sold, -6p plus 600. It's that times the price. So this represents the number sold. This represents the price. How many you sell times what you sell them for is how we get our revenue. And this revenue is a function of the price. Now, if we clean that up a little bit, we get that the revenue function is -6p squared plus 600p. And this is a quadratic. So when we look for quadratics, we will use those skills that we've already previously learned to answer the rest of these questions. So this is the model. This is the question to answer to A. Now, question B says, what is the domain of R? Assume R is non-negative. You wouldn't be in business to lose money, so we're just interested in where the values are non-negative, so 0 or higher. So what that means is we're looking at where is this equal to 0? What are the zeros of this parabola? -6p squared plus 600p. And we want everywhere between zeros. So this is an upside down. So to give context, this is an upside down parabola. It's going to look something like this. We want to know where are those values because we're interested in all this in between. And all this in between is where we're making profit. So if we find the zeros, we will know the range that we need to be focusing on to make money selling these products. So when we set it equal to 0 in this type of equation, I would actually factor this. I would take out a greatest common factor of, I would say -6p would be a common factor. And that would leave me with p plus, if I divide, that wouldn't be plus, that'd be minus. That would be minus 100. And I can check that by saying, if I were to multiply this back in, would it give me what I originally had? So -6p times p is -6p squared. That checks out right there. And -6p times -100 would give me positive 600p. So I would say that's good factoring. The zero product rule says if I set each of these factors equal to 0, I will know the zeros of this parabola. So, well, the first one just gives me p equals 0. That's nice enough. The second one, if I add 100 to both sides, I get p equals 100. So when the price is listed, if we sell it for between 0 and $100, that is where we will get our profit. That is all this space in between. So the domain of this, the domain is from 0 to 100. Now I'm using brackets because those values would give us 0, and it says non-negative, that it does include 0. So the domain, the prices we're looking at would be between 0 and $100. Now the next question is C. What price maximizes the revenue? Well, we talked about maximum minimums in one of the previous videos, and this is a function. I guess this is the p-axis. But we want to know is right up here, this value right up here, that is where the maximum value is, because this is the money axis, how much money we're making. And so I want to know where is the vertex, because that is going to be the maximum of this revenue function. And so if you recall back to the previous video, the way that we find a maximum or minimum value is looking at the vertex. And the way we find the vertex was we look at negative b over 2a, and that'll tell us the x-coordinate. So it'll tell us right here. Let me change colors. It'll tell us this right here, the axis symmetry, the x-coordinate of the vertex. And so if I look at my equation, so just to rewrite it, so revenue as a function of price, R of P equals negative 6P squared plus 600P. If I identify my A, B, and C here, well, there is no C. That just means C is 0. But A would be negative 6, and B would be 600. So to find the x-coordinate of my vertex, x equals negative b over 2a, so that's going to be negative of 600 over 2 times negative 6. So that gives me negative 600 over negative 12, which gives me 50. That'd be $50. So the question was, what price maximizes the revenue? Or what is the x-coordinate or the p-coordinate of the vertex? And that is $50. So a price of $50 maximizes the revenue. So the answer to C is $50 is the x-coordinate of the vertex. It is the price that maximizes. Now the next question, D says, so what is the maximum revenue? That's a fancy way of asking when the price is $50, that maximizes the revenue. What is the revenue? So what is the y-coordinate that goes with that input of 50? So all that means is we need to use what we found, the negative b over 2a, and that value, 50. We have to plug that back in to see what does it actually give us when we have a price of $50. So what we're finding is instead of R of P, now we're saying the price is 50. So we're saying, what is R of 50? We're going to evaluate this function when the price is 50. So that means negative 6 times 50 squared plus 600 times, oops, not P. We're now putting in the precise value. So that's 600 times 50. Now, I do not expect you to do this in your head. I'm not even expecting you to do it on paper. I'm pulling out a calculator right now, and I'm going to solve this as well. So let's see, negative 6 times 50 times 50. Oops, I screwed something up there, didn't I? Negative 6 times 50 times 50 again. So I get negative 15,000 for that right there. And then 600 times 50 gives me 30,000. So I have negative 15,000, and then I have 30,000, which means my revenue when I charge $50 a pop for this product would be negative 15,000. 30,000 gives me positive $15,000. So I make $15,000 in revenue. So the vertex, the x-coordinate of the vertex was $50, and the y value would be 15,000. That is the vertex. That is where this revenue is maximized. Now the last question says, how many units are sold? So if you remember, initially the equation given was x equals negative 6p plus 600, where x is the quantity sold and p is the price. Well, the price we know is 50, which means to figure out the quantity sold, I can once again just plug in 50. And so I have x equals negative 6 times 50 plus 600. I get negative 300 plus 600. So x equals 300. There were 300 units sold of this product. So we are taking what we know about parabolas, maximums, minimums, how to find the vertex, all those skills we talked about in 4.3 we are now using to solve real-world problems. So we have 300 units sold. We have the max revenue at $15,000. We have the price that maximizes revenue at $50 a piece.